Okay, so this is our last lesson in solutions. This is lesson 6, and what we're really going to concentrate on today is explaining how a solute's effect on solution comes into play. And this really has to do with freezing point depression and boiling point elevation. And it is tested on the reagents. And then the last thing I'm going to go over is how to prepare a solution of known concentration. So colligative properties for electrolytes are based on the number of particles. And I'm going to explain right now what I mean by that, and then I'm going to go over it again in a little bit. When we look at NaCl and we put that into water, it dissociates, so this is my solid, into its ions, and we've talked about this in class. Na plus aqueous and Cl minus aqueous. So this dissociated into two ions. Whereas if I look at something like CaCl2 solid, this is going to dissociate into Ca2 plus and 2 Cl minus ions. And that gives us 3 ions. So when we're talking about based on the number of particles, we're really saying based on the number of ions. And we're going to come back to that. Recall that an electrolyte is a substance that produces ions when dissolved in a solution, because the ions are free to move around, meaning they are mobile, and we know that ions are charged, they have a plus or a minus. The solution is able to conduct electricity. And it says salts, and that's because salts are the best at this. However, it is not just salt. It is also acids to some degree and bases, and we'll talk about that when we get to that unit. But I don't want you to think it's just salts. And you're going to say to yourself, well, how do I know what a salt is? How do I recognize a salt? A salt can be recognized because it's going to be a metal and a halogen, so that's your group 17, or a metal and a polyatomic combined. So that's how you recognize a salt. It says it's the same concept as mobile electrons in metals, but not the same thing. So metals conduct because they have mobile electrons. Solutions, various solutions conduct, solutions that are acidic, basic, or salted, because they have mobile ions. When a solute is dissolved in a solvent, the solvent molecules surround the particles of the solute. We've already talked about this. We know that what the attraction is with water and various ions in solution. When this happens, it causes the boiling and freezing point of the solution to change in a very specific, predictable way. So when we're talking about boiling point, the boiling point increases when solute is added. So when we add salt to water, it allows you to boil the pasta at 102 to 103 degrees, so it cooks faster. A lot of you think you put salt in water so that the pasta doesn't stick together. That's not the real reason. The reason is because it will take longer for the water to come to a boil, but when it does, it's boiling at a higher temperature, so it takes less time to cook the pasta. Freezing point depression is when the freezing point decreases when solute is added. And you had a whole article that you did last marking period on driving in winter roads and adding salt. And it's the same reason. Putting salt on roads causes the ice to melt because it drops the freezing point below 0 degrees. So normal freezing point of water is 0 degrees Celsius. When we salt the roads, it may be 1 to 2 degrees below 0. That is now the freezing point of water, depending on what salt or what kind of salt we're using. So why do we salt roads in the winter rather than sugar them? Well, let's look at sugar. When we take sucrose, which is covalent, C12H22O11, and we put it in water, so this is your solid, it dissolves and it still stays intact, C12H22O11, and that's aqueous. So you have 1 mole of reactants and 1 mole of products. It doesn't dissociate. If we take NaCl solid, as I showed you earlier, and we put it in water, you get Na plus aqueous and Cl minus aqueous. So you have 1 mole of reactants and 2 moles of product. The general rule is the solute that dissolves to form a greater number of products or ions will have the greater freezing point depression, so freezing point will decrease by more, and a greater boiling point elevation. Boiling point will increase by more. So CaCl2 dissociates in the presence of water into Ca2 plus aqueous plus 2 Cl minus aqueous. So this is a total of 3 ions. Well, 3 moles of ions, sorry. 3 moles of ions. 1 from here and 2 from here. So even though CaCl2 depresses the freezing point more than NaCl, why don't we use it to salt our roads? And the bottom line is because it costs more money. So let's just review that. Covalent compounds don't dissociate. Covalent compounds always 1 particle. And ionic compounds, you need to look at the dissociation reaction. And count the number of particles. So that's what I just did when I wrote NaCl going into Na plus and Cl minus. That is a dissociation reaction. So you might want to do this and just label this as a dissociation reaction, so you know what I'm talking about. Okay. So let's look at NaCl, Mg, I2, and Na3PO4. So which one of these would effectively have the greatest impact on boiling point elevation and freezing point depression? Well, right away you can see this is 2 ions. This is 2 and 1, this is 3, and this is 3 and 1 PO4, which is 4. So this one would have the greatest effect on freezing point depression and boiling point elevation. Okay, lastly somewhere, I wanted to talk to you, and I'm not saying that this is going to be on the test, but it could be on the Regents, so you need to have an idea of how do we make a specific concentration of a substance. And there's two ways. The first way is an example, and I've talked about this because we were doing molarity, is I need to prepare for lab a 3 molar solution of MgSO4, and I need 500 milliliters. So I'm doing lab prep. I don't just go in my back room and pull 3 molar MgSO4 off my shelf. First of all, it only comes as a solid. So I actually have to do math. Every time I prepare solutions for lab, I have to do math. And I have to do the same two equations that you've been using. So I've got my molarity equation, which equals moles over liters, and I have my mole equation, which equals given mass over GFM. So I know that I have a 3 molar solution. I don't know how many moles that is. I know that 500 milliliters equals 0.5 liters, because milliliters I divide by 1,000 to get liters, so 0.5. So this is going to give me my moles, right? Cross multiply and divide, and my moles equals 1.5. So now I can come over here and use my mole calculation. So I've got 1.5 moles. I'm trying to find the given mass, and I can calculate the GFM of MgSO4. So I've got 1 mg at 24.305. I've got 1 s at 32.065, 4 oxygens at 16. So my GFM is going to be 120.37. So 120.37, and I solve for given mass. So I'm going to multiply 120.37 times 1.5, and my given mass is 180.55 grams of MgSO4. Well, now what do? I'm going to go get a beaker of water, and I'm probably going to put at least 400 mils of water in it. So I get my beaker, okay, I fill it with 400 mils of water, and I put my 180.55 grams in here, and I get a stirring stick, and I stir till it's dissolved. Then I go get a flask, a graduated cylinder, and I want to get one that's 500 mils. And I'm going to dump this dissolved solution in here. I'm going to dump all this in here. And then, obviously, I'm not to 500 because I said I was going to have about 400 in here. Then I'm going to take distilled water and I'm going to fill it so that the meniscus is just at the 500 milliliter mark. And do that with distilled water. And then I have my solution. And that's what I have to do every time I make solutions. Now, some of my solutions are liquid, like the acids, a lot of the strong acids. So let's say, or suppose that I needed a 3 molar solution of HCl. and I needed 250 milliliters. Well, this is a liquid, so what do I do now? Well, there's a slightly different formula called M1V1 equals M2V2. And this is referred to as a dilution formula. And it's not on your reference table, but you should know about it. And it basically says if I know the molarity and volume of one, I can figure out anything about the other. So I know that I want a 3 molar solution and I need 250 milliliters of it for lab. Well, in my stock room, when I buy hydrochloric acid from the company, it only comes as 12 molar HCl. This is your stock solution. So I know that I've got 12 molar, and I don't know how much volume. So I simply solve for x, and I get x equal to 62.5 mils. And that's of the 12 molar HCl. So what do I do next? I'm going to do right what I did before. I'm going to get a graduated cylinder. This time I can get one that's a 250 milliliter graduated cylinder, and I'm going to pour the 62.5 mils of 12 molar HCl in there. So this is your 62.5 mils of HCl. And then I'm going to fill it up with distilled water. So the meniscus is right at the 250 mil line. And then I have my solution. Okay, that's it. Please don't forget to watch the review video, and please don't forget to work on your practice test. And make sure you saw the update with all the upcoming events for the next week. Thanks, and enjoy your snow day.